Yep. Yeah, thank you to the organizers for having me here in beautiful, sunny Bergen. So the weather's been wonderful. Everybody's like, it rains all the time. This is going to be a technical talk. I have a lot of slides to cover. If we don't cover anything, I'm going to publish the slides just because this is kind of a reference of everything that changes. So yeah, we'll be doing kind of all the technical things that have changed in Crossplane v2. Just a little bit about me. I'm a principal solutions architect at Upbound. I've been there over 4 years. I also contribute a lot to the Crossplane project, functions, reference platforms, and things like that. And I kind of move around a lot. I have a base in the United States, but I also spend a lot of the year in London and Italy. So, and one thing that connects me to Bergen, I grew up in New Jersey, in the United States, a town called North Bergen, New Jersey, which kind of overlooks Manhattan, right? So we're in the Palisades. If you're at like 82nd Street on the Upper West Side of Manhattan and you see all those cliffs, that was kind of the neighborhood where I grew up. So I do have a connection, I feel like, to Bergen. All right. This is going to be a technical talk. So there have been a lot of amazing talks about platform engineering. I'm going to kind of talk about just the engine, the technology underneath it. And we're first going to start talking about Crossplane. I think if you folks don't know what it is like, what if you could take Kubernetes and use it to manage everything, right? So that you could take the Kubernetes kubectl API, apply to create something, and you have controllers that run all the time. So that's kind of the idea of Crossplane. Like what if, and this came about, about 5 or 6 years ago when the CRDs were exploding in use of those, and it was like, can we take those CRDs and use those as a basis to manage everything? So there's a few things that Crossplane does. So the first one is that every single resource that we manage is a Kubernetes CRD. And that includes platform abstractions, right? So we've heard a lot of talks about platform engineering. Like when you create an abstraction for your end users, that's a Kubernetes CRD. So they could use Argo CD or Flux or anything to provision it. The next thing is there's a vast ecosystem of things to manage, right? So how do we extend Crossplane? And that's providers, right? So Crossplane, again, it's a universal control plane. So what we do is we have providers that continually reconcile resources all the time. So if something changes in the remote cloud provider, within a scanning time, that'll be reverted by the provider. And then finally, a big thing in infrastructure and code in general is like, how do we create the desired state, right? Like, there's tools like Ansible or Terraform has HCL. Pulumi allows you to write in different languages. Crossplane has a really interesting way of doing it. They use almost like serverless functions, right? So what happens is it's like a GitHub action pipeline, and you could write your functions in any language. What happens is Crossplane sends a standard message of the manifest and all the observed state of the cluster, and that's like a blob of JSON. So you could write your desired state in any language, and I'll show you that later. So it's super powerful, actually. I myself use, there's a language here called KCL, the top one. That's one that I use a lot, but we've seen a lot of our advanced customers starting to write in straight Go, right, using typed Go to create things. So, and I think that's kind of the evolution of where platform engineering is going, that it's more and more approaching like SRE, where people are just writing pure controllers to manage everything. All right. So, and we're going to talk about V1 here. There's a lot of changes in V2, but the core idea of Crossplane is this idea of a managed resource, right? So what you see here is this is a CRD, and you can see it has a kind and an API version and metadata. These are all Kubernetes things, right? So other things that are very central to Kubernetes, there's a spec. This is your desired state, and we have a provider. Like this is one of the standard Crossplane field. It's a for provider. There's a provider config ref, which we'll talk about later. That's how you authenticate. If it's like a Kubernetes cluster or database, if it creates a secret, we could return that automatically, and that gets refreshed. Every time we pull the cloud provider, and if the secret changes, we'll update your secret in Kubernetes. And then finally, there's status, right? Like, how do we get things back? So this is all Kubernetes status. And what I haven't put here is like things like events, right? Like you can have events are emitted as things change. So you could hook this into your logging system. Also, all providers have Prometheus metrics. So you can monitor the status of almost everything on a Crossplane cluster. Just expose that to Prometheus. And coming in 2.1, we have some really cool metrics coming out where you can customize and have custom dashboards that really examine what's happening to all your resources. Because what we find in Crossplane is that people are managing thousands and thousands of resources on these clusters. So yeah, in this case, we have API version container, like everything, and then it's a cluster kind, right? So Crossplane has one kind for every single individual resource that is out on a cluster. So this one would actually manage a GKE cluster in Google. Okay. The next concept, we're building platforms, right? So that's a building block, a managed resource, but we want to build complex infrastructure, and that's an abstraction, right? So I just want to talk about a couple parts here. We talked about, and these are where we start getting some definitions, so I want you to think about this more as like a menu, right? So this is your platform abstraction, right? So imagine you create a YAML that says, these are the fields I could ask for. Like if a developer wants a database, you're not going to give them all the fields to tune, right? What you're going to say is they can maybe request, up to 500 gigs and certain instance types. And then you make that available on the cluster, and then if they have Argo CD or Flux, all they have to do is check in a YAML file that requests that, and then Crossplane will provision it. So that's your custom platform. How that is done in the back is something called composition, where it takes all the individual parts. Like if you're doing an RDS instance, you'll know you need a subnet group and maybe the instance itself, right? So those things would be managed together. And then what comes out of that is the composite, right? Which is like, think of like the end result of like a Terraform module, right? The composite is the actual, the resource that contains all the sub-resources in it. And the way Crossplane works is a little different than other tools. If you know something like Terraform, it pre-computes the graph, right? Of all the things, Crossplane works in a Kubernetes native way, and I'll say this all the time, Crossplane is very Kubernetes native. So we manage everything asynchronously. Like when things are created on the cluster, everything just goes in parallel. And you could obviously put some dependencies on things between each other, but the default behavior is that everything is managed in parallel. So one thing here is that everything in Crossplane v1 is cluster scope, because that was kind of the style at the time, except for namespace claims, right? So what would happen is the idea here is that there would be like this relationship. The claim would select like, certain XRDs based on what they're asking for in parameters. So there'd be a decoupling of what the customer is asking for versus the provisioning system. So this is how it works in Crossplane v1. And it still works in Crossplane, but we're moving to v2. And just quickly about the Crossplane components, these are just ways you talk to the Kubernetes API server. So the managed resources and your platform abstractions are all stored on the API server. So this means that things like Caverno or any access policies that you have on the API server validating webhooks, you could apply those to your infrastructure, right? Like you don't have to have custom things. You can just have that all be guarded there, plus things like OIDC and access. The Crossplane core runs as a pod, and its main job is to run the function pipelines. So when a user asks for something, the function pipeline's invoked. It comes back with all the desired states, all the different things it needs to provision. Those are put back to the API server. And the way Kubernetes works with controllers is that the providers watch for the things that they're managing. Like a GKE provider will look for a cluster kind. And when it's talking, Kubernetes has a very sophisticated internal system of things like informers and updaters. So as soon as something changes, the provider's notified, and then it could start making changes. So like, I grew up in DevOps, and we'd have things like Jenkins that we'd run every hour, that we'd do a git diff, we'd see if anything was changed, then we'd run a Python script, then we'd run a shell script. A lot of those differences and everything, all the changes are handled within the Kubernetes API server for us. All right. Okay, let's talk about things that are not great about Crossplane v1. That as we were growing with customers, the problems we were seeing. There are a lot of issues with this model. So what I'm showing here is like, there's namespace scope things and cluster scope. So most of our customers don't want to have things in cluster scope, right? They want to deploy applications and their infrastructure together in a namespace. So the assumptions that the team made back in 2018 didn't really hold up for platform teams. The other thing too is we're over abstracted, right? We use something called provider Kubernetes to manage Kubernetes objects because we wrap the Kubernetes objects with all the extra cross-plane resources like observation policy and things like that, management policies. So this again was kind of like too much of an abstraction. And finally, this claim to composite, if you've ever had problems with Kubernetes server-side apply, this actually caused a lot of issues in terms of debuggability, and sometimes they would have conflicting fields. So we spent a lot of time fixing up them fighting over fields and making it so the claim owns certain fields and the composite owns other things, but it's been a very buggy interface. So in Crossplane v2, pretty much everything is namespace scoped. Crossplane doesn't need provider Kubernetes anymore. It'll just manage things directly, and claims are gone, right? So everything is much simpler in the next model, right? This is what it looks like now. We have no more claim. Crossplane will just manage everything together, right? So we could just drop this in a namespace. The provisioning of everything is much simpler. So yeah. Let me do a quick, I'm just going to do a quick demo, just to show you if you've never seen Crossplane. Let's see here. While I'm doing this, how many people have ever used Crossplane or know about it here? Okay, we have about half. Awesome. So, I might show, let me see, can I show this? For some reason, my screen is not showing there. See if that gets it. Very good.
So we need to mirror the screen.
Okay. Yeah. Which one do you know? Okay. I apologize for this. Do you want to? Yeah, thank you. Yeah, so what I'm going to demo here is I'm basically, well, he's figuring this out for me so wonderfully. Thank you. We'll have to go back when I change it.
Yeah, of course. So it will be the same as...
This will be like this will be like 2 minutes.
So then you find back the demo, yeah.
Okay. Sorry for the delay. So I just want to show just a really quick example of what a native looks like, and I will make this a lot bigger. Okay. I'm just going to deploy this right now. And I just applied a manifest to the cluster, that's it. And what that does is that creates a bunch of Kubernetes resources. So what you can see here, it's creating an app, and underneath it, it's creating a deployment and a service, and some other things there, right? And you can see this is the composite there. So before we'd have to have like provider Kubernetes. And I could do things, let's go here. You know, one of the nice things about Crossplane, we talked about the internal API mechanics, right? So if we create this, if we change this app and then we trace it again, you could see instantly it's already got creating 5 pods, right? So as soon as you apply something to the Kubernetes cluster, the informers kick off and the function is kicked off again and the changes are made almost immediately, right? So in the time it took me to apply it, the containers were already updating themselves. So Crossplane, there's a lot of, and it's getting better in 2.1, there's a lot of machinery within Crossplane to make it real time, right? So as things are changing, it creates a bunch of watches on both sides. So it's watching what the user is asking for, and it's also watching the state of all the resources. And every time one of those changes, it can reinvoke the functions. So Crossplane is very dynamic in the system that way. One thing I talked about was that you can configure Crossplane to write in any programming language, right? We said that. So I'm just going to show a few examples of that. So the first one I think that most people would understand who are in Kubernetes is we have something, function go templating, and this is inline, but what you see here is that this is basically about 95% the same as Helm, right? So this is a function pipeline, and what you see is an inline template, and then what you're doing here is you could just see, we look at the observed status, we could get here, we could set a ready status, right? So we could do things on the resource. So what happens is when this function is invoked, it has the context for all the resources that it's managing. And then based on that, it could do dynamic changes on the fly. Now, because Crossplane has a standard mechanism, it uses gRPC messages for sending things to the function and getting data back, it's very easy to write SDKs. So if you look, like we have Python, which is very similar, right? You could see here we're doing something similar. In this case, the Python is really simple. They just take a JSON blob and they just update the resource, right? That's what they're doing here. And then finally, there's composition KCL, which is a language that's very good for doing desired state kind of things. And again, so you could program in almost any language, and you can mix and match them. Like you could have pipeline steps like a GitHub action, so you could have things that are written. You could have built-in functions. There's some functions that only do one thing, and I'll show that later. So that's kind of like the core essence of Crossplane, that you can be very powerfully doing things. All right. Let's see if we get, are we going to have to unmirror it again? Or? Okay. All right. So that's kind of some of the figure of V2. So first, we're composing apps and infrastructure together, better isolation and multi-tenancy. And then we're going to talk about something really cool that's built upon kind of the real-time engine of Crossplane, and that's something called operations functions. All right, so this is a big need in infrastructures, like how do we run things that are outside of managed resources? Because are these kind of resources continually reconcile, right? So what do we want things to run periodically or be triggered? So there's two types of operation functions, and for folks who know Kubernetes jobs and cron jobs, it's almost the same thing, right? Like we're abstracting that out. So cron jobs run periodically, and they run the same type of pipeline. So if you've already built functions, you can just run them, instead of all the time, you could just run them periodically every few times. And then watch operations are really cool. Something, because we have the Kubernetes API server, we could take advantage of this. You can watch like a config map, and if a config map changes, you could go do something else, right? You could kick off a function and say, hey, if this database has changed, go kick off a backup, right? There's all kinds of things you can do, and this is all dynamic within Kubernetes using watches. So an example I want to show is something, I'm not going to demo it, but I'm going to show an example that one of my coworkers made. Let me just do this first. So this is how they get triggered off, a watch operation, and it's like a cron job. It creates a template for the job, and one thing that's cool about these operations is you inject the resources. Because Crossplane, the functions you saw have all the context of all the resources that it's managing. So when you create like a watch operation, you could pull in additional resources from the cluster, and they will be available to the function. The function will have the spec and status of those, and it could do things. Like it could go update a field, it could add labels. They can't delete. There's limits on what operations functions could do right now. They can create objects and modify them, but they can't delete. And you generally don't want them fighting over fields, right? Like Crossplane, like in Kubernetes, you don't want two things fighting over the same field because they'll both get into a reconciliation loop because they both are determined to own it, and they're going to own it no matter what. It's like the Terminator. They will do everything to get it to the state that they want. So if you have two competing over a field, so what I want to talk about here is something. Kind of an interesting experiment that one of my coworkers made, and this is using Claude to dynamically resize databases using the Crossplane primitives. So the first thing is we just have a standard SQL instance. So this is a database. You're running a platform, a user asks for a database, and you provision it. That's what we have here. He wrote a function called RDS metrics. So what this does is this runs, and when it runs, it fetches all the databases. So you label your databases of who you want to collect metrics for, and you say what metrics. This function will run, and then it'll populate the status of that SQL instance with the CloudWatch metrics for that database. And then what he does, he runs a cron operation and uses function Claude. So basically, Claude is invoked. It looks at the status of the metrics, and then it decides whether this database should be sized or not. So I'm going to show you, let's see here in code, what this looks like. So we're going to go to our, so we could just look here at main K. So this is in KCL. And one thing I'm showing here too is this is coming to Crossplane upstream. This is outbound, but you can see here we're using KCL, and this is all typed, right? So we generate types for each programming language from the CRDs. So if you've used something, that has like visual code and things like that, you can, I could put metadata here, and we have the spec and the RDS instance. So yeah, if you want to add things, you could just like find a field that you want to put there, and it automatically fills. And it's all typed and everything. You can see here that the type is inferred, right? So I could say just double click and it'll insert the type. So that's really powerful. This is what we see a lot of. And the other thing about our DevX experience that's being merged upstream is we also have things like operational tests, right? So we do end-to-end tests where you actually provision all the resources and bring them down. This is kind of state-of-the-art for platform engineering right now, where it's built into our platform. And in fact, our commercial product does this on the fly. When you run a test, it brings up a control plane that lives for a few minutes until it's provisioned, then it tears it down. And then there's also regular tests, right? So this is a big thing we talk about, just the developer experience of building platforms. And so if we go for the, let's see here, we're going to look at the operation. And what the operation does is it invokes function Claude. And it tells it what resource it's going to monitor. And then it just has a prompt and a system prompt, right? So this is actually sending this prompt up to Claude with the data that it's received, checking the analysis of scale, and these are the things that it could do. And then it just has what it has to what it needs to set. So this is actually, it takes a while for this to catch up, like, because usually we have to scale the database and see what happens. So for a short talk, it's usually not. But this is kind of just like a really interesting use case where we're starting to see, like, what could we do in terms of, also when there's like an error message, can we run Claude against that to see if we can decipher what the error message is? This is especially good for like a platform when people don't understand when something went wrong. Can we explain better the error messages? One of the downsides of this approach is that running Claude is very expensive, right? Like if you're constantly invoking it, this could be really expensive. So I don't know if it's better just to have Claude write a function that does it and invoke that. But yeah, it's, this is something that we've been playing with, and we're getting a lot more into like intelligent control planes of what can we do. We have so much access to real-time data in these clusters, like what kind of things can we do? Cool. All right. Okay. So, and I'm going to start going into some of the features. I may not go through everything, but just talking about, like, if you're an existing Crossplane user, what does it mean? Right now, if you're an existing Crossplane user, you could go to v2 without almost any issues. There are a few deprecated features that you may have to convert, but generally, you could just go, and then at your own pace, you could start using the v2. Even the new providers, v2 generally can run on v1 clusters, just the cluster scope parts of them. And so I'm going to talk about just managed resource updates, what's changed. And this is going to be a little technical, so I'll hopefully not. The first thing is API groups now have this little M here. So as soon as you see this, you know this is namespace. This is kind of the convention for all cross-plane resources. So keep this in mind. Obviously, namespace support. And something really tricky is that when they release the 2.0 providers, like cross-plane providers, whenever there's an API change, like in the CRD, cross-plane providers will generate a conversion webhook, right? So you see some of these providers go to v1 beta 3, v1 beta 2. That was all reset with the latest. It's a small technical thing for people who are heavily using crossplane. The next thing is, and these are, Crossplane used to have something called the deletion policy, and you could say either delete or orphan. If it was set to orphan, that meant that it would get deleted in Kubernetes, but you would leave it out in the real world. You know, you do this if you want resources that don't go away, because we've had many people who have lost infrastructure for various reasons. So yes, it's always it's almost like a rite of passion that someone deletes all their infrastructure. I hate. For various reasons, it's good to do it early. You can now, like, so Crossplane managed resources could look at other resources on the cluster and like pull their fields out of them. Like this has to be built in. For example, in this case, a resource group name ref means that it knows how to pull a resource group from an Azure resource. This is built into the provider. So this used to be cluster scoped, now it's namespace scoped. And then the other thing too is, as we said, that Crossplane resources could write secrets. They used to be able to write them anywhere, now it just writes it to the local namespace. And then I want to talk about provider configs because I talked a little bit about authentication. So how does Crossplane authenticate, right? And, you know, when I was, using Jenkins, we used to just store secrets into a Jenkins job, and that was like the shared secret for all 500 jobs that we used everywhere. Crossplane has this concept of a provider config, which is an abstraction that kind of decouples the authentication from what the user is asking for. So in this case, the provider config contains things like every provider has a custom way they design it, but like for AWS, there'll be IRSA, there'll be web identity, there'll be static credentials, right? So you can authenticate in different ways. Like if you use web identity authentication, that means the credentials will be put onto the node, right? Automatically, they'll be injected by Azure or AWS onto the node, and it gets rotated dynamically, right? So as long as you set up the proper trust relationships, it works. And one of the really cool things is because we run on Kubernetes and there's OIDC everywhere, we could actually do really good cross-cloud OIDC trusts. So like you can have a GKE cluster provisioning things in AWS, just using OIDC trust relationships between the two clouds. So it's really powerful. Again, because we're built on Kubernetes, we have all these cool features. You could also use secrets. So you could see here, everything was cluster scoped in v1 except for things like secrets. This was a little bit of a security headache. What we do now is everything obviously is namespace, but there's also, so the pattern for everything now is we leave v1 alone and things are added to v2. So in this case, we have a cluster provider config. Let's say you have some type of shared auth that you don't care if it's shared among all the teams. You could put that up there and the user will just ask for that. Otherwise, by default, they will get only the provider config in their namespace. This is just that. One thing I showed in my demo, and this is something I think that will be fixed in a future version of Crossplane, but managed resources automatically would handle things like ready status for you automatically in Kubernetes resources. Crossplane doesn't have that yet, so if you are building stuff that's native yet, you have to set the status of it. So this is an example in Go templating. What we're doing is we're just using a shortcut function in Go templating, get the resource condition. If it's, in this case, you know, the status is available on this, so if that is, then just set the ready state to true for the resource. And obviously, different Kubernetes resources have different availability resource types to map to ready, so I just think we'll probably have a function coming very soon that automatically handles all of this. I talked about provider Kubernetes. This is what we used to use. You could see here, we'd create an object kind and then wrap like a namespace. This was the old way of doing things before we did things automatically. There are still some cool features about this. You could still observe resources. The nice thing about Kubernetes is if you give it a kube config, you can manage things on another cluster. So that'll probably be the main use case for provider Kubernetes going forward. All right. How are we doing? This is a lot of technical information. So another thing when you run Crossplane at scale, you discover is that you hit the limits of Kubernetes a lot. And one of the things we found out about 3 or 4 years ago is that Kubernetes doesn't really handle a lot of CRDs really well. It handles objects really well. Like you could deploy thousands of objects, but when you start deploying more than like 700 or 800 CRDs to a Kubernetes API server, a lot of them will go into shock. Especially like Google was constantly rebuilding itself. AWS actually handled it very well. Now, of course, we've created namespace CRDs, right? So we've doubled everything. So I did a survey this morning, and just between the 3 providers, main 3 cloud providers, there's over 4,000 CRDs, right? So this would, if you installed the providers and everything, this is how many CRDs you'd have on your system. And this is, you know, this is why we created family providers. If you look at Upbound Crossplane today, you'll see that like the big cloud providers are broken up. There's an S3 provider. There's a Google Container Service provider, right? Like we had to break up because otherwise the API servers couldn't handle it. What we're doing in V2 is we're actually creating something where you decide as a platform owner what CRDs are put onto on the system. So here is what it looks like. So in this case, what we're saying is we're just going to create for AWS, and you could say exactly what. So in this case, we want to have the namespace bucket resources, and here we're just saying specifically, just these 4 are the only things we want on the cluster, because maybe we don't want people asking for them. You could either also do cluster scoped here. One thing to remember that caught me is that it's a plural of it, right? Like if it's not plural, it won't match it. So this caught me the first time I was playing this. The other thing too is you could do a wildcard if you just want to load everything. So this is a way to keep the number of CRDs on your system manageable. And we may go back to monolithic providers now because we could do this. Like, so we spent a couple years breaking all the providers apart. We may go back to having just like a big provider that everything is filtered of what you can install. Just to do this when you're installing Crossplane, just said there's a default. By default, Crossplane doesn't do this. It's actually, it will install everything and overload you. So what you have to do is when you install Crossplane, you want to turn off default activations. So just something to keep in mind for the people who are moving to Crossplane V2. All right. Just a couple changes in compositions in V2. We talked about in the beginning, again, the same thing. V1 is not changing. V2 adds a namespace and a cluster scope type for compositions. That's the main thing. The main difference here is that a cluster scope can actually, like if you have a namespace platform abstraction, right, that you're saying, like, let's say my team network, right? If that's a namespace, it could only provision things in that network. If you make it cluster scoped, it could provision things anywhere on the cluster. So it's really about what kind of isolation you want to have for your platform abstractions. Right? And here are the scopes here. And I'll just leave them here just for, there's namespace and then there's legacy cluster. All right. This is a small technical thing that probably doesn't bother anyone in the world, but I added it for completeness. Just basically, we tab one field under spec Crossplane because otherwise it was kind of in the junk drawer with all your parameters there. So just a little bit of cleanup. Another thing is that Crossplane, these abstractions that you build, like your application, used to be able to write secrets automatically. With the removal of claims and a few other things, it simplifies it a lot just to leave that up to the composition authors and not have that part of the XR. So this is something, this is not the local secret. This is like when you build your platform abstraction. So, well, all right. I want to talk about something else. This is for folks who don't use Crossplane a lot. Like, how do you order deletion, or how do you prevent things? How do you prevent from not deleting your entire infrastructure? This would probably be a good thing for most people. We have something called a usage kind, and what you say is, you say that, like in this case, we don't want to delete an EKS cluster until the Helm release that's provisioned on it goes away, right? Because otherwise we can't delete the Helm release because the cluster's gone and it's going to keep erroring out. So what you do is you create a usage, and when you create a usage in Crossplane, it creates a webhook that basically blocks any deletes on that resource, and it returns a forward 9 error. Right, so this is how you could prevent, this is how you could do deletion ordering. And when this Helm release is deleted, the usage will be gone, and then the cluster will kick off deletion. Obviously, this is cluster scoped, same thing. There's a cluster usage, and you can see here the API changed, so now they do protection.crossplane.io. So this is a really important thing as you're building a platform, not only building it, but when you're tearing it down, right? Like we talk about end-to-end testing and all those other things, like it's really important, the ordering of tearing things down, making sure that there's really complex relationships between a lot of things. So a lot of folks use usages for those. All right. This is, again, because Crossplane is so Kubernetes, you get to learn a lot of things about Kubernetes when using it. Crossplane doesn't have admin roles on the cluster, right? So if you want to manage things like in this case, ingress, right? That's not a core Kubernetes type. You actually have to add the cluster role, and we use something called aggregation. So if you see there, the aggregate to Crossplane, that label, what that means is when you create this role, it will automatically be aggregated to the Crossplane user and service account, right? So this is how you add extra permissions. So we're using Kubernetes aggregation for that. All right, and then things that we've gotten rid of. So I'm going to talk about these. These are the things that we cleaned up and got rid of the core of Crossplane. The first one was when we first released Crossplane, we had like this static engine that was like patch and transform. It was like using Kubernetes patches, and it was built into Crossplane itself before we went to functions, right? We've been trying to deprecate it for a long time because functions are just so much better than this. And you can just take, there's a conversion tool where you could just take, if you have any of these existing, you could just convert it to a function. So this is totally removed from the code now. Controller configs, like when you run providers, you want to set like how much memory, CPU, labels, and things like that. So we have like a deployment template that you could do. We used to have something called a controller config, but that's been replaced. Again, there's tooling that you could just convert if you have one. This is an interesting feature that almost nobody used. We used to have ability to like publish to external secret stores when we publish secrets. It was used so little that we ended up removing it, and even you know, a lot of folks are just using external secrets operator to push things. And then finally, image registries, right? So Crossplane uses a lot of Docker images, and you could specify a default at one point, but that caused a lot of complications for people who are like in air-gapped installations, right? So a lot of folks running Crossplane are in very secure locations right now. So we have this thing called an image config now that came out recently, and the image config allows you to do things like rewrite prefixes, verify signatures of images, and do other things like that. So again, all right. And finally, the last thing I want to show is just a new tool that just got released like a month ago. And that's basically Crossplane diff, probably one of the biggest things that folks were asking for. And that's like, how do we compute changes? And because, again, this is Crossplane is a desired state system, right? So a lot of the architects are like, when you say it, that's what's going to happen, right? And then you get a lot of people from the Terraform world who are like, well, I run everything in a big job, and I want to know what's happening. So, you know, the last speaker here was talking about culture and communication and everything. So sometimes we have to have therapy. I don't know. So what we're doing here is that this Crossplane diff, what it does is it actually looks at a resource that you're asking for changes on, and what it's going to do is it's going to examine the Crossplane cluster, pull everything locally, and run the function locally to compute the diff. Now, I'm doing it now because instead of pulling a bunch, so I just did this and it just came back. I have cached all the Docker images to my local system. So what you could see here is that it's going to come back and say what fields are going to change. So like if I applied this local XR to my cluster, these are the fields that would change. Or I could do something like new, right? And it'll say, it will compare what's out in the cloud versus what's here, and it'll compare it, right? So this has been one of the highest. So this is under very heavy development, but I know a lot of folks are using this right now, just in terms of like putting in CI pipelines. All right. Okay. So Crossplane 2.0 came out in August, and we spent a lot of time fixing it and getting the ecosystem filled out. For KubeCon 2.1 is coming out, and this is mostly going to be fixes. There are a few things, especially like in the real-time engine, there's been a lot of corner cases that we found where things don't work very well. One of the most important things I was talking about this, if you've ever used something, a Crossplane project called Xmetrics, this is by the author of that. What's going to happen is you can apply CRDs to the cluster, and you could say, I want to monitor this and emit these status, right? Because people want to say, how many buckets do I have for this team that are healthy, right? And you'll be able to do those kind of things with Xmetrics. So we should have, I don't know if it's going to make Crossplane 2.1, but it'll be pretty close. So we'll, I think, continue to have some of the best metrics. And then, what we emit. And then thank you very much, everyone. We're going to be at KubeCon. I won't be there, but we'll have the Crossplane booth there for anyone who's going. And Upbound will be there too. And you can join the Crossplane Slack. And I will post these slides since there's so much information. Yeah, and at that, I'm done. Thank you. Do we have any questions from? Has anyone deleted all their infrastructure? Oh.
If I noticed correctly, you mentioned that the provider config is namespaced.
Yes.
So does it mean that for every provider like AWS or Azure, you have to write the config into the namespace?
Yeah.
How you authenticate it?
Yeah, usually the config is like 5 lines. It's like, point to a secret, or use web identity, or use an ARN. Okay, so it's written, the provider has all the logic. Does that make sense?
Yeah, so you just specify which method to use, but not the authentication itself, kind of.
Right. Yeah, you can just say, hey, use this ARN to provision. That's what,
Do you have any thoughts on how this new way of doing it with namespaces and native Kubernetes resources in Crossplane 2 compares to the upcoming Crow?
Not exactly. I think it's a general trend, though, that we're seeing that more and more stuff is moving to like dynamic Kubernetes objects, and more. I think we're going to see Kubernetes taking more and more things over that are DevOps workloads, right? So I think like Helm 4 is coming out, and that also has some kind of plug-in logic to do things dynamically. So I think we're just starting to see this model come through.
Yep.